Welcome to Tech Talk with Steve. My name is Steve Cowles, Product Manager for AEM Test. Today we're going to have an episode with a standards update on single pair Ethernet. So we're going to talk a little bit about that and about how you can test single pair Ethernet, what it is. We'll try to answer some questions. I know for some people, single pair Ethernet may be new. For others of you out there who are involved with it, probably understand quite a bit about it. So welcome everybody. I'm going to have two special guests with me today. First, we've got from AEM, Arvind Patel, who's our Director of Engineering for the Test and Measurement Solutions Division at AEM. He's a product engineer with over 20 years experience in electronic circuits and RF systems. He's been involved in the design and development of test and measurement solutions for the cabling industry for the last 15 years. He holds a tech in electronics and communications engineering and a master's in electrical engineering from the National University of Singapore. Arvind loves traveling and being with nature in his free time. Welcome, Arvind. And
hello, everyone.
We've got,
good day.
And we also have with us Bob Voss. Bob from Panduit. He's a distinguished engineer with Panduit, their corporate research and development located in the Jack E. Cavney Innovation Center. His practice areas are industrial automation, building automation, and the Internet of Things. That's what we're all about here. His domain expertise includes 4 decades of control engineering, industrial network architecture. In addition, he's one of the design contributors to Panduit's LEED's Gold World Headquarters Automation Design. His Panduit responsibilities include technology leadership for strategic alliances and partnerships, futurist activities for industrial automation, and executive support research. He represents Panduit before several standards and development organizations, including IEEE 802.3, the TIA TR42, TR60, IEC, and NEMA. Bob chairs the ODVA, Ethernet, IP physical layer, SIG, an engineering subcommittee within ODVA tasked with specifying the ideal physical layer for the Ethernet IP. Bob also chairs the Ethernet Alliance SPE committee, single pair Ethernet. Further, he is a contributing member of the Converged Plant-Wide Ethernet Architecture team. Wow, that's a lot. Welcome, Bob.
Hi, Steve. Hi, Arvind. How are you guys doing?
Good, good. It's great to have you guys here. So, we'll get started with Arvind here in a minute, and then Bob, we'll follow up with you. Just for anybody who's just tuning in, we are going to be talking about single pair Ethernet. Arvind's going to go over some standards information on SPE, where we sit right now. We'll talk a little bit about testing, and then we'll follow up with Bob. And Bob is one of the predominant gurus in this technology. So we're really excited to have you here, Bob.
Thank you.
And I will let Arvind get started.
Okay. Hello, everyone. So, Steve, can you see my slides?
I can.
Okay. So I'll give an update on the single pair Ethernet standards progress and where we are right now. So the single pair Ethernet standards have been evolving for a number of years now. So starting with the IEEE 802.3 working group develops the Ethernet networking standards, and the 802.3 BW was the standard in 2015 that started off with the 100 megabits per second operation over a single balanced twisted pair cable. This was mainly driven, I would say, by the automotive industry, and it had length restrictions for up to 15 meters. Followed by that was the 802.3 BP standard in 2016. This allowed 1 gigabits per second operation over a single pair copper cabling. This again was limited to a 15-meter distance, mainly driven by the automotive industry. Right? So this has been almost like, I would say, 8-9 years since single pair has been around. It's mainly in the automotive, but we are going to see a lot more changes happening, and the single pair Ethernet will be more widely seen in other areas as well. The 802.3 BU standard This is the power over data lines for the single pair twisted pair Ethernet. Again, this is specifically for the earlier two standards that were developed. The latest standard, which is the CG standard, this is the standard of interest to many of us today. This is the 10 megabits operation, and this allows to have a reach of up to 1,000 meters, probably even beyond that. And it also has the power delivery information. Right? And this standard also has information on the multi-drop configuration. So we'll look into the 10 megabits more in detail in the following slides. There are some new standards on which IEEE has been working, which is the CH, which is the 2.5 gig, 5 gig, and 10 gigabits. This again is targeted at automotive industry and limited to a 15-meter distance. New developments, which is the DA, this is addressing the 10 megabits single pair multi-drop. So the IEEE has, it has had a number of standards related to single pair Ethernet, I would say, for the last 8-9 years. The ANSI TIA standard, which develops the cabling standards, the 568.5, this is the latest standard which has been approved for the single pair cabling. There is a 568.6 standard which will start development, which is for the single pair multi-drop. So this will allow multiple devices on a single cable installation. There is a 568.7 standard. This is specifically targeting the industrial premises segment, right? So we have 3 standards under TIA, which will be the 568.5, .6, .7. The TIA 5071, this should be approved in a couple of months. This is specifying the field test instruments and measurements for the single pair cabling. So for the ISO IEC, there is the technical report, which is the 11801-9906. This is an application specific single pair Ethernet cabling up to 600 megahertz. There are developments ongoing for the 11801 amendment, which will also have more details on the different types of single pair cabling in the upcoming drafts. For the field testing, there is the IEC 61935-4, which is in the draft stage, and this is addressing the field testing for single pair cabling. Right? So this is the summary of all the standards in the SPE, which is very detailed, a lot of information, and with the 568.5 approved, I think the details of what is required for installation is very clear, and we'll look at that in the next couple of slides. To give you an overview of what is contained in the 568.5, there are 2 categories, which is the SP1-1000 and SP1-400. The 1000 will go up to 1000 meters using an 18 gauge cable. This is again, there is a limitation on the DC loop resistance of 50.6 ohms. With the 23 gauge cable, you can do 400 meters. And again, this is having a loop resistance requirement of 61.5 ohms. So 2 categories defined in the TIA standard. The frequency range of measurement is much lower than what you have for the 4-pair cabling. It only goes up to 20 meg. But you have a lower frequency cutoff, which is for the 4-pair, it is 1 megahertz, whereas for SPE, it is now going to start from 0.1 megahertz. Right? So this is going to be different compared to the regular 4-pair cabling. The connector that is defined in the TIA 568.5 is the LC style of connector. You have the picture on the right, the plug and the jack. So this is specified in the IEC 63171-1, which is, it's called the LC style. It has the same dimensions as the fiber optic LC connector, but instead of the ferrule, you have the two copper conductors. The channel definition for SP1-1000, this is a 1000-meter channel with 10 connectors, right? So this is the definition. You can have less. The maximum is 10 connectors in the channel. And for permanent link, the maximum length defined is 950 meters with a maximum of 9 connectors. So this is like a brief summary of the 568.5 overview.
Hey, Arvind.
Yes, Steve.
Could I ask you a question about that last slide that you had up there?
Yeah.
One, you mentioned earlier that you may be going beyond 1,000 meters. Do you know how much further beyond 1,000 meters we might end up going?
So in the 568.5, the limitation is there for 1,000 meter, and there is a delay spec, right? And this is all defined based on the 18 gauge cable, which is specified in the standard. But if you look at the IEEE definition, they have a much bigger allowance for the delay, and it is possible to use a 14 gauge cable that will allow you to do 1,500 meters.
Wow.
So it is, I would say, strictly speaking, for TIA, the limit will be 1,000 meters, but I will not be surprised if people try to stretch this using custom limits and try to reach, distances beyond 1,000 meters. It is similar to what you are seeing in 4-pair, where a 4-pair, category 6A cabling is a 100-meter channel. But today, you do have installations which go up to 150 meters for the 10 megabits, and mainly targeting, the security camera installations where you don't have a need for high bandwidth, but you need, just 10 megabits.
Yeah, and they're using heavier gauge cable, just like
Yes.
you indicated here. It would be a 14. Yeah. So you thicker cable, lower resistance. Yeah, it makes sense. Thanks.
So that is possible. Strictly speaking, for certification point of view for cabling, it would be 1,000 meters, and then probably there will be variants depending on custom use cases.
Okay, thanks.
Okay, so this is a list, I would say, different types of SPE connectors that are specified in the IEC 63171 standard. So the first one, which is the -1, is the LC style, which is what we have in the 568.5. And then you have -2, -3, -4, 5, and 6. There are more coming up. A few other proposals are there. So it is possible to have, I would say, multiple variants of installations of different types of connectors. Right? So you have the -3 is a Terra connector, which is, again, this is split. This is just a single pair variant. In the -6, you have a new connector from Harting, which says Harting in the company name, which is, again, that is also, I would say, popular in the industrial space. And then the -5 is the existing M8, M12. What we foresee people doing is you could have 4 pairs, and then you could split them up into 4 SPE channels using the M12 4-pair connector. Right? So that is also some of the configurations that you would see users using this. You have the -4, which is the BKS connector. Again, this is a 4-channel, 4-pair connector, but it's basically like an aggregation. So you could have 4 SPE in a single connector. Okay, so we'll look at some of the, from the field testing perspective, that is the parameters that need to be tested for single pair. The insertion loss is defined in both 568.5 and CG. So this is a requirement for measurement. Return loss needs to be measured, again, from both ends of the cable. Now this 1,000 meter is a long segment, right? So the two ends of the testers probably are not visible to each other, right? And you would need the field tester to be able to be smart enough to detect a connection and do measurements from both sides. Right? There is a TCL requirement for unshielded cables for specified in the IEEE as well as the TIA standard. If it's a shielded cable, this does not need to be tested. Right? So this is the TCL is the transverse conversion loss, which is the unbalanced measurement in the cabling. The DC loop resistance is critical. This is an important parameter for power delivery. Right? So the single pair power over Ethernet delivery will need to consider the DC resistance to determine how much power you can get at the endpoint. The delay specified. So Steve, this is the point that you mentioned. On the right hand side, you have the TIA requirement for the delay, which is 5559 nanoseconds. This is using the 18 AWG cable for a 1,000-meter distance. The IEEE spec has a 8834 nanosecond delay specified. That is if you were to use a 14-gauge cable, right? And this would be equivalent to roughly around 1,500 meters. So in terms of power delivery, so for single pair, it's going to be tricky. If you are laying a cable for 1,000 meters using 18-gauge cable and 10 connectors, you would have 7.7 watts at the endpoint. Right? You could get more if you had less connectors, but this is the limit specified in the, I would say, in the standards based on the resistance. If you need higher power, let's say 20 watts, then the distance would be shorter. So you could only do like say half the distance, and you would be able to get higher power at the endpoint. Again, if you reduce the distance further to even half of that, like say 187 meters, you could go up to 52 watts of power at the endpoint with 2 connectors and 18-gauge cable. If you use a 23-gauge cable with 2 connectors, you would need to reduce the distance even further to 58 meters for the same amount of power that you would need at the endpoint of 52 watts. Right? So this is, like I would say, a complex matrix. The power delivery at the endpoint depends on the gauge of the cable and the distance to which you are laying the cable, because it involves the resistance as well.
Yeah, it seems like it's the same. We're using the same math we use for regular PoE when we're trying to figure out how far we can go based on the resistance of the cable. So it's just now we're interpreting it for this longer distance and a lower power level.
Yes. So okay, so here we have, this is a snapshot of the Test Pro tester, which has the LC style connector. So you see the picture on the left has an LC adapter. This is a 100-meter cable drum which had the LC connectors at the end point. It's a 23-gauge cable, 104.8 meters with a loop resistance of 14.4. So and this is the physical adapter which has the LC connector right at the end, right? So this is a standard adapter that fits into the Test Pro. You could plug this out. You can plug out the 4-pair cable, and you could plug in the single pair. And this is the LC connector that you have. So components are slowly becoming available. Cabling is available. The connectors, I would say, they are gradually being made available. So it should be possible to have installations given that the standard is approved. Just a couple of snapshots of the tester. So the first picture on the left is the wire map. So you can have 2 wires in a cable, right? And then you have the shield, right? So in terms of the standard limits, the middle picture is the TIA 568.5 SP1-1000 limit for a shielded cable. And this on the right hand side, it will give you the summary of the measurements. Right? So that's about it for the single pair, the standards update. And the capabilities that we have in Despro.
Okay. I know that if for anybody that's putting questions in there, we will address questions at the end after we hear from Bob. I would like to point out one thing that I think some people who aren't familiar with single pair Ethernet might not get, and I'm sure that Bob's going to talk more to this. But the idea is that SPE is not going to replace our existing Ethernet architecture for our local area network. It's designed for more of the IoT stuff, like the building automation controls, sensors, PoE lighting, signaling, alarm systems, all that kind of stuff, rather than replacing our computer network itself. Correct?
That's absolutely correct. Really, what we're targeting is that edge of the network, because it's a lot of disparate siloed networks today that are not Ethernet. And that's troublesome, because from a beginning standpoint, it's a business continuity risk for customers. If you're operating a building, if you're operating a factory, and you're highly dependent on legacy protocols at the edge of the network, the guys that fix it have my hairstyle, gray. And guess what gray-headed people do? They retire. So, that creates a continuity risk. So the capabilities you gain by deploying Ethernet are going to help you address that initial business continuity risk. And the neat part about single pair Ethernet is during its birth for industrial in the CG standard for industrial and building, is we looked at topologies. We looked at what jobs they hire those legacy topologies to do, to steal from Christensen. And single pair Ethernet is set up to do it. The two jobs that are non-Ethernet, if you will, today, absent of single pair Ethernet, are long distances. We're capped at 100 meters, and the ability to multi-drop between devices, which Arvind talked about a little bit in his presentation. So we have that capability in the CG specification to do multi-drop, and we have the capability to do long distances. Another parlor trick that Ethernet does better is it delivers power. And right now we use local power with a low voltage control network connection that does not deliver power when we're using legacy protocols. So it's a pretty big uptick in terms of capability. I guess the other thing I'll touch on that's kind of, table stakes with Ethernet is the fact that you're going to gain Ethernet security levels, IP security. Today, security at the edge of the network with disparate legacy protocols is done through security by obscurity. You don't know what it is, you don't know where it is, so it's secure. No, it's not secure. And in fact, hackers don't care what the temperature is in your conference room. Hackers want to get a hold of that sensor and say, what's connected above it? What's connected above it? What's connected above it? And suddenly they're, pretty high up in your network and having fun and, stealing your money and messing with your business. So just that gain in cybersecurity alone is an enormous benefit to adopting single pair Ethernet.
Gotcha. So it actually keeps the devices on the SPE are separate from your main network.
Right. And so, like the converged plant-wide Ethernet, which is a reference, a validated reference architecture that's built and tested by Cisco, Rockwell Automation, and Panduit. We have a demilitarized zone in between the enterprise portion of the network, the voice and data business systems like SAP, Oracle, email, all that kind of stuff, and the factory. So you go into the DMZ to find information from the factory, and the factory communicates through the DMZ into the enterprise. They never go directly to each other, because that's just enormous cybersecurity risk. Plus, you're going to get silly things like Patch Tuesday, where they roll out, all kinds of good software to your laptop. If that hits the factory floor, machines start to crash. Mm-hmm. So you want to keep those activities separate from each other. But it's a really cool thing. The other thing about the really good look that we gave to industrial and building automation applications in IEEE is the cost aspect. We could probably do some of the more sophisticated devices at the edge of the network, like a variable frequency drive, or something that needs a lot of data and has a lot of information coming back from it. You can do that economically with 4-pair Ethernet, but most of the stuff at the edge of the network just can't bear the cost of a 4-pair PHY. It can't bear the cost of the precision magnetics that have to happen at the edge of the network. So single-pair Ethernet also addresses a very real concern of cost at the edge of the network, so that things can be done, I won't say cheaply, but things can be done with the right sized cost profile, if you will. And I guess the other thing is that, you know, the voice and data network, there's people with laptops and nice test equipment that get the voice and data network running. The edge of the network is electrician. That it's guys with big fuzzy gloves and Klein lineman's pliers. It's not really super sophisticated stuff.
Right.
And it doesn't need to be. It needs to be more robust than a finicky thing with 24 gauge wire and 8 of them. You got to land just right. And don't untwist it too much or the connector is going to mess up. You know, so I won't say fault tolerant, but I think it's a little bit more. Single pair Ethernet is a little bit more tolerant of normal installation practices. It can be landed on a terminal strip and still operate at 10 megabits. It is better being connectorized, obviously, but you don't really pay a decrement to continue using terminal strips in some applications. So it's neat stuff.
So one question I've got with regard to SPE, and I'm going back to my early LAN training days, when it was into my head that the reason we have the 100 meters is not necessarily the cable is limited to that, but you start to run into timing issues with the network where you get collisions if it's traveling a certain amount. Is SPE different in that matter?
Well, I think Arvind talked a little bit about a delay spec, and I think you'll see that that's a little bit different for this sort of thing. We're critical. For example, at the edge of the network, we look at drop packets or missed packets. And because of machine timing, because there's moving parts, there might be a robotic arm with an end effector on it that's controlled over that link. If we get 2 consecutive drop packets, we pause the machine. If we get 3, we shut it off. And it boils down to a life safety and an equipment safety issue. So we're not tolerating collisions as the same way you would in a LAN, where you say, well, man, I don't know how big that PowerPoint was you sent me, Steve, but it took forever to download it. And that's just me going, well, there's collisions, and, you know, it took a long time for that 1 megabit file. But, you know, because of the fact we're controlling motion, because there's workers near the things in motion, we're very critical about that anywhere in an industrial network. So the bit error rate's very good for single pair Ethernet. The performance is great, and I think it's right sized.
Gotcha. And it's you know, lower speed, right? We're only going up through 20 megahertz frequencies. But Arvind, you did mention earlier about an ISO standard that went to 600 megahertz. Is that going to be a higher speed version of SPE?
Yes, Steve. You know, because if you notice the automotive segment, they have 100 megabits and they have 1 gigabit. So the 1 gigabit speed in the automotive for the 15-meter distance, that has a 600 megahertz bandwidth.
Okay, so it'll be short distance, more geared toward that type of application rather than building automation.
Yes.
Gotcha. That makes sense.
So hot on the heels, Steve, of CG, which is 10 megabits at 1,000 meters. A lot of people, when we were originally evangelizing this version of SPE, the 10 megabit SPE, said, okay, you could do 10 megabits at a kilometer. What could you do at 100 megabits? And, well, a prayer will be answered, because there is a group in IEEE right now that's just coming out of study group and will become a task force this summer that is looking at higher speed, like 100 megabits at a shorter distance. So we're going to have a catalog of speeds there besides just the 10 megabits. We could reach up into the automotive PHYs and get some really fast stuff over short distances, but there's also going to be that moderate speed in the 100 megabit range. Probably something on the order of 500 meters.
Oh, wow. And that would open up, additional devices at the end of that SPE, more things that we can control over SPE.
And from a building standpoint, if you want to do video cameras, now you've got a conspicuous distance. As Arvind pointed out in his slides, with that shorter 18 gauge cable and fewer connectors, we're going to have more power available. So security cameras in a parking lot, that sort of thing, opens right up.
And we did have a question pop up. How about power delivery? And maybe the person tuned in after you had that slide up, Arvind, but can you just kind of summarize what we're expecting with power delivery?
Okay, so
and that would kind of play in with that camera too, because for SPE, if you've got a camera you want to get power to, you could run the power and the data over that SPE like you're talking about, right, Bob?
Mm-hmm. Absolutely.
So, Steve, can I share my? You could bring up
Sure.
my slide. Okay, yeah. So let me jump to the slide which had information on the. Yeah. So this is sort of a summary of the amount of power that you could have on SPE. So the CG standard defines the protocol and the requirements for power, right? So at a distance of 1,000 meters, you could get 7.7 watts. So this should be good enough for small security cameras that need, less power. Probably, some cameras you could get for like 5 watt, 6 watt cameras. So, they should be able to work. Industrial equipment, sensors, actuators, they should also be able to, this amount of power is good enough for, those type of devices. If you need more power, then of course the distance will be shorter. But, this is all based on the 18 gauge requirements, right? And there could be, we currently see power delivery over copper on like 12 gauge cables, which is used in the mines, mining industry, and they go up to 500 meters distances. They use thicker gauge to lower down the resistance and deliver power over. This is the hybrid fiber cable that I'm mentioning, right? So they use single mode fiber for data, and then 2 copper conductors up. They could be like 12 gauge of 12 and go up to 500 meters. Right? So
right.
Here we have 18 with 7.7 watts. Probably a gauge of 14 could, give you even higher power, right? And
right.
I've mentioned here is purely 18 gauge is what is there in the standard, but users could get more power by using a thicker, lower resistance cable.
Gotcha. And another question we had on that, there was the frequency range for 568.5, .6, and .7. Now with the .5 you showed, that was 0.1 to 20 megahertz, if I remember correctly. Is there a difference in frequency range for the .6 and .7?
No, those will be, we're really only in TIA addressing 10 megabits per second with the standard now.
Okay.
So yeah, it'll all be that 1/10 of a megahertz to 20 megahertz.
Okay, gotcha. And we did have a question.
7 is all 20 megahertz.
Right.
Gotcha. So one question that came to mind is, so if we can do this for a single pair Ethernet, and we can go these additional distances, and eventually maybe go higher speeds, what's the possibility of doing a 4-pair Ethernet that's going to go these extended distances? Do we see that as something that might be, a on the wish list down the road from a technology standpoint, or is it just really not something that we think is feasible?
I think you see application-based things now where UL and Annixter Wesco have created a program called UTG, where they will look at a particular cable and a particular connector set and a particular application and can warrant it with test data to say, yeah, you're good to more than 100 meters here.
Right.
I mean, especially in industrial and buildings. I'm sure, what's 2 or 3 meters among friends, but we're talking about some significant extension of distance. I think the standard is going to remain 100 for a while until we get, IEEE always looks at broad market potential and looks at interest, so can we extend that 100-meter standard, and what benefits do we deliver to the industry in doing that? Nobody's brought that forth yet. There's a new Ethernet applications ad hoc that in 802.3 that is the wellspring for that sort of a thing, and I'm a member of that ad hoc, but I've never seen anybody come in and say, hey, how about stretching a standard longer? So
yeah, and like Arvind mentioned earlier, there are some who are using different gauge cables and whatnot to get as much as 130, 140, 150 meters out of it, and they're seeing success with that. So I think it's kind of, you go back to what I call the early days. I'm showing my age. Back in the 90s when I first started getting into this stuff, it was all, the standards actually got driven by the technology, right? And I think it's still the same way. Whereas as the technology develops to meet the needs out there, we're going to start to see new standards. And if that need exists to have a 4-pair Ethernet to go 500 meters instead of 100 meters, we'll see that. Maybe not in our lifetime, but eventually something will happen.
I agree.
It's and there's only one more question we got from people who jumped on here. This is my friend Davey over in the UK. Are the adapters available to purchase today? So right now we do have one. We've got one of the adapters for SPE in the line. We're going to be adding more. And again, they just plug into the Test Pro just like any of your other adapters. And then you select the appropriate test limit for single pair Ethernet. So it's it's the adapter and the testing functionality built inside, designed for it, as Arvind showed on his slides earlier. So Bob, Arvind, anything either of you would like to add before we wrap up today?
I guess one of the things I want to touch on, and it's important since we have a premium test instrument manufacturer hosting this call, is cable reuse. When we talked through IEEE about being able to support the topologies, and in fact, single pair Ethernet media is very similar to what's used for these current legacy protocols. The ability to potentially reuse electrically healthy cable comes up because it's already installed. Why drag new wire, right?
That's right.
So the fact that, Arvind and I have seen each other in all of these IEEE meetings during the standards development over the years is because the test instrument people need to be there and say, yes, that cable is electrically healthy. You could safely reuse it, or say, no, get new. This is not, because especially in factories, the things that degrade cable are available in abundance. Heat, humidity, corrosives, all kinds of bad stuff's there. You don't want to bet your job on trying to save a couple bucks on cable, but so that to me, that's very exciting that we've been shoulder to shoulder during the standards development, so that not only will we be able to commission new networks, but we'll be able to give fact-based answers to, can I reuse this cable? And that's exciting for me.
Well, and that makes a lot of sense, because that kind of takes that what I would call, the non-structured cabling, low voltage cable, your 18.2s and things like that, that maybe people didn't think about, when they put them in. Oh, we're going to put this in for this right now. If we change up, we're going to have to change cabling. We went away from that with network cabling to have a unified structured cabling system that can accommodate just about anything based on, the limits of the cable. And a lot of times we think about that. You install it, you've tested it, you got it up and running, and people forget about it. Oh, it's good, it was tested. Well, 10 years down the road, the cable's not the same as it was when you first put it in. So it's really good to check your cable. Even though things are working, might not be a bad idea to run some tests. Spot check some cables. But in a case like this, where you're talking about reusing, it's the same thing. If you're going to do new applications on structured cabling system, you really want to test the cabling, make sure it's going to be good enough to support the application. So that's
important.
Yeah. But it hadn't even dawned on me about them being able to use it, because they've already got the wiring in place for door contacts and motion sensors and all this other stuff. Why not just you test it for SPE and see if it's going to work. So that makes absolute sense.
The other important part about instrumented testing too is what some of the things we're finding, because at the Innovation Center, we've kind of got a single pair Ethernet center of excellence. So we've had partners and customers come to us and say, this is our standard cable. It says it's 100 ohm characteristic impedance like single pair Ethernet says in the standard. Can you test it just to make sure? And we'll put it on our test rig. And what we found is some of the cables that are out there that say on paper 100 ohm characteristic impedance, that 100 ohm characteristic impedance is based on 31.2 kilobits per second. It's really slow traffic. You start pushing 20 megahertz through that same cable and it says, ow, and you don't get the 100 ohm characteristic impedance you need anymore.
Yeah.
So
well,
testing.
Yep, exactly. And since you mentioned the Innovation Center, anybody out there that's watching this, if you ever get a chance to go to Panduit's Innovation Center, do it. I got to visit it several years ago, and it's probably even more fantastic now than it was back then. But there's a lot of cool stuff, and Panduit's been on the leading edge of this type of stuff, and that Innovation Center is really impressive.
Thank you. Yeah, it's a neat place to be. There's 18 labs, 250,000 square feet, a couple hundred employees in there, and you wouldn't recognize it. I know we hosted you. You got to come back because it changes all the time.
Yeah, I definitely need to get back up there again. A lot has happened with technology since I was there years ago. We didn't have as much stuff being driven by PoE, all the PoE lighting and window shades and everything else. So that wasn't even, maybe more than a twinkle in somebody's eye back then. So, but yeah, I'd love to get up there and see it again. Arvind, anything you'd like to add before we wrap up?
No, I guess we covered, Bob covered all the application side. I think we have an overview. I think another important application, which I would say is the multi-drop. So you could have a single installation. I guess it could go up to 40 meters. That's what work is ongoing. And you could have multiple connections over the same cabling. So you could, it's like tap out. And this used to be done earlier on in the original Ethernet, networking over the coaxial cabling, right? So that is
the bus cabling over 50 ohm coax.
Yeah. Mm-hmm. So I think now with the single pair, again, we will have that same configuration being made available to users, where you could have, let's say if you have like 10 locations where you need to tap out, to sensors over a distance of 40 meters, then you just need to lay a single cable and tap out. Right? So that's another powerful application that I think users will benefit from the single pair Ethernet.
And that's a topology that's fairly common in a building. We don't do home runs from the occupancy sensor to light switch, the VAV, we start at the light switch, hit the occupancy sensor, pick up the VAV, and we're doing that with an RS-45 network now. So the capability of being able to do that with single pair Ethernet is enormous and very important.
And is that going to be done more like a daisy chain, or will it actually be like taps? Okay.
Yeah, it right now it'll probably be taps. There is some study in 802.3 DA, which is a task force that's in work right now, to augment the multi-drop that's in the CG standard today. So that'll probably get more distance, more nodes, and we'll address the daisy chain versus tapping.
Great. Looking forward to continuing to watch this evolve. It's fascinating stuff. Well, Arvind and Bob, I appreciate both of you joining us today. This has been fantastic. A lot of good information here on single pair Ethernet. I really appreciate it. Just to let everybody know, there's also on April 21st, there's going to be a cable installation and maintenance webinar, additional standards updates, not just single pair Ethernet. So we'll be participating in that as well. And Jack will post a link in the comments section about that so everybody can find it. Bob, Arvind, really appreciate your time, and thanks everybody for joining us today. We'll see you in a couple weeks.
Thanks for having us, Steve. Appreciate it.
Thank you, Bob. Bye-bye.
Thanks, Arvind.